again welcome to my presentation on academic trip 2, which is take 400 academic trip 2. My name is Joseph Kirema. I'm very happy to present to you this virtual trip that you have undergone. And before I start my presentation, I want to thank the management of Moi University, and specifically to our department is Technology and Education. Many gratitude and thanks be unto you. Now, in academic trip 2, we have undergone 4 things. One of them is about the one part is about the area of specialization, which is automotive for me, and the other one is for computer. In the area of specialization or automotive area, we have undergone or I've undergone. One of them is about now the comparison between the aluminum engine block and the cast iron engine block, and the other one is about now the petrol engine and diesel engine. The third or the part of computer, it has 2 parts also, one of them being the scan or what you call supervisory control and data acquisition, and about the remaining one is about the industrial internet things. Now let's start from the part of automotive, which is about now aluminum and cast iron engine block. For those who doesn't know, engine block is a part of engine, and it is one of the biggest part of engine. And in just for few or just for elaboration, engine it has 3 major parts, which is one of them is about the cylinder. The second one is about the engine block, and the other one is about now the crankies. Now, of the three parts, engine block is the biggest part, and it can be termed as the backbone of the engine. So engine block is made up of 2 different materials, one of them being aluminum and the other one being cast iron engine block. Let's start from the cast iron engine block. Iron engine block are normally cast by gray cast iron, and these are just the iron and the constituent or the component that are used to make iron so that they can make engine block. These constituents, some of these constituents is carbon, silicon, manganese, sulfur, and phosphorus. The advantage of being or having the engine block which is made up of iron, one of them is that it has relatively low cost of manufacturing. In terms of cost or in terms of manufacturing, it is very low comparing to the aluminum, but we shall look on the aluminum. Then it provides good machinability and good galling or what we call wear resistance. It does know that wear resistance very low. Then it has higher tensile strength when compared with aluminum. Tensile means you can't tear it easily. It is very okay. It is very appropriate. And the disadvantage, even though it has an advantage, it also has some disadvantage. One of them is it has heavy weight, which is very disadvantageous when we come to compare it with aluminum. The other one, it is larger in weight, means more fuel equipment, and in terms of fuel economization, it is very poor in that area. So that is about now the cast iron engine block. Then let us look on the aluminum engine block. Aluminum engine block, as we have said in the cast iron, it is also made up of some constituent or component, and these components include aluminum, silicon, magnesium, copper, titanium, iron, zinc, nickel, manganese. We have disadvantage and advantage of this kind of engine. One of the advantages of aluminum engine block, it is lower weight. Remember in cast iron we said about it has heavier weight or more weight than the aluminum. So this one, it has lower weight when comparing with cast iron block. And the lower weight now bring the other advantage about the fuel consumption or high fuel economy consumption or emission. The disadvantage of aluminum engine block, it is more costlier, or in terms of manufacturability, it is more cost, not like the iron which is less cost, and it does not have a good machinability that the gray cast iron has. Good machinability about now is about the manufacturing, and also it has a lower tensile. Remember, cast iron has higher tensile. Now let us look on the other part of automotive, which is about now the petrol and the diesel engine. Both of them, since it is a comparison, both of them is the internal combustion engine. Both of them are internal combustion engine. Then before we had no internal combustion engine, but due to the technology now we have internal combustion engine. Different, or basically, when do they refer to one engine as a petrol, the other one as a diesel? Basically, it's about the fuel that is used. In petrol engine, petrol as a fuel is used, and the other name for petrol engine is now what you call spark ignition engine, and the other name for the diesel engine is what we call combustion ignition engine. Both of them, they undergo what we call stroke. Especially the common vehicles have what we call four-stroke, and these four-stroke mainly are, one of them is about the induction. I'm going to explain them after I've written, and the other one is about the compression. Then the other one is about the power, and the last one is about now the it is now about the exhaust stroke. Now let's see how or what happened in induction. Induction in when we even come back to the engine block, induction is now whereby inlet valve open, whereas the piston move from top dead center to bottom dead center. Thus it allows the air fuel mixture in case of petrol engine, and in case of diesel engine it allows air to get in through the inlet valve. That is about the induction. Note the movement of piston and what is coming on in respective types of engine. Now let us come to the compression. Compression now, it is whereby the piston now has reached to the bottom dead center. Now it is moving up from BDC to TDC, and it is compressing whatever gets in, especially to the petrol is about the air fuel mixture. It is compressing, and to the diesel is about the air. So the work of in the compression stroke, piston move from bottom to the up, and in now the power is now in terms of petrol engine, the spark ignition, or there is what we call ignition of power. After the compression has done and that temperature it has reached, now we have now the spark. It is ignited, or it ignites the air fuel mixture, and then we get the power. That is now when the vehicle start moving. In terms of this engine, we have the fuel injector. It injects the fuel to that heated air, and it produces the power, and that's the time now you see the car start moving. Now let us come to and before I come to the exhaust stroke, in both compression and the power stroke, the inlet and outlet valve remain closed, whereas in induction, inlet valve is open, outlet valve is closed. Now let's come to the exhaust. After the car has produced power and it has gone, you need now, after the power stroke, the piston move from bottom dead center to the top dead center, and now the outlet valve is open to allow the exhaust or waste to come out of the engine. One thing that we're going to get here as a difference is about the petrol engine. It uses petrol, and diesel uses diesel as a fuel. Then petrol engine has what we call spark, and in diesel engine we have what we call fuel injector. Fuel injector is in engine. Now let us come to the land part, or the second part, which is about now the computer. We have what we call supervisory control and data acquisition. SCADA was first developed in the 1950s, and from that time it has evolved from the uses of microcomputer and telephone relay. And the architecture, or the first, or the generation of the SCADA, it has been having generation due to the technology. It is advancing now, and then it is advancing from the first generation in other one is called monolithic. This is the original SCADA came into system when there were no networks. First system was not designed to connect to other system. Remember, there's a time that we had no network. That was about now the first generation. Can you look on the second generation of the SCADA? Second generation is also known as a distributed. Difference from the first generation, this second generation took advantage of local area network. Local area network is simply called RAN, And we have now the third generation, which is networked. Remember the first one it took place when there was no network. Then the second one, now it is about the local area network. Now the third one is about now the networked is also called networked communication of a wide area of a network. That is one, and the utilization of PLCC. And for monitoring was achieved in this generation. Monitoring is like a control. Fourth generation is now called Internet of Things. Internet of Things we are going to discuss in the previous, and simply it is about now it is aiming to making the manufacturing smarter, controlling, monitoring everything. Oil and gas, food manufacturing, communication, waste management, all of those are made smarter or improved by what we call Internet of Things. Can you look on the third part or the last part of the computer, which is about now the implication or impact of edge computing and Internet of Things system in industry. According to philosopher or someone known as Gamma, edge computing can be defined as a part of distributed computing topology. Distributed means wide areas, not just at certain area or localized area or centralized area. Basically, edge computing is what keeps out ends above the water in massive land for streaming. And basically is about now Internet of Things devices where milliseconds count is about now the data is collected, it is brought back to the edge devices, edge computing devices or Internet of Things devices that now react immediately. What is the now impact of the edge computing to the Internet of Things specifically for this area? Internet of Things is divided into three ways depending on the type of use. Either you are the customer or enterprise or even you are a consumer. Those are now the types of Internet of Things. They are divided according to how they are used. That is how now they are divided. The main objective of Internet of Things is to remain to be control and monitor in order to provide operation efficiency. The main operation or the main objective is to control and monitor to provide that we call efficiency. Now, there are many benefits that Internet of Things get from edge computing. Benefit like latency or enabling the information to be faster, enabling the information to reach and reach where it is supposed at the right time. Then we have bandwidth. Many IoT devices send many small packets to the data package management. The other benefit that the edge computing enables to the IoT is about the edge computing can enable processing and filtering of IDC generated data closer to the devices, apart from now when we have the very far. The other benefit is about the security and about now the reduced operation costs. That is how now the edge computing benefit IoT or what we call Internet of Things. There are specific requirements for Internet of Things. Everything need to have requirement, and some of this is that internet companies are looking forward to roll out engine compatible with various networks using what we call common off-shelf or a server that will have no specific hardware. Then the main part of computing or edge computing, we have hardware, software, and those are now the main part of edge computing. So as I said earlier, thank you very much for watching. Thank you very much for being with me, and may God bless you.